Hi everyone, I'm Robert Cleeley.
And I'm Taspa Slis.
Yeah, and I've just suddenly thought we should probably check that these videos have been working, Tassos, because if they're not, we've spent all morning recording these videos and we haven't checked that they actually work, so hopefully the microphone works.
Yeah.
Or we're in for a bad afternoon. So what we wanted to do now was think about, we've conducted a factor analysis, we've settled on what we think is a reliable factor for purchase intention, but now we want to go back to the data and score every respondent in terms of that factor.
To the particular factor. Yeah.
So there's a couple of ways we can do this. As part of the Cyc package's factor analysis functions, it's possible to score the items using a variety of statistical methods, many of which are replicated in SPSS. So you could use a regression method to do this. So we could.
The most common is the regression method, Bartlett's or Anderson's. There are other methods. We tend to use the regression method. It's the most straightforward. Yeah.
So if we go back to our syntax, our code to create our second model, the one where we removed one of the items, so we've just brought it straight back up. So we've got using the factor analysis function on this data set, using maximum likelihood. We set score to regression.
Right, so we just add another parameter, we just call it to do another job essentially.
And if you wanted to use a different method, we just type it in here.
Type it in,
Now, this is an interesting one because looking at the documentation, the default is if you don't set a method in regression as regression or whatever it might be, it defaults to false, which means it doesn't calculate the scores. So you have to tell it to calculate the scores. So once we've done that, we now have those scores and we can look at them if we want to by calling
scores
model2 and scores, I think, with an S, and there you go. So it's got each respondent with their score calculated through the regression method. Now Tassos was just explaining to me very eloquently some problems with this method of scoring.
So here we have essentially scored the factor as we should, at least in terms of data, or at least in terms of statistics. The problem with these numbers, as we can see here, is that they are all centered around 0. So we have negative values and positive values, ranging from -2 to plus 1 point something, as we were seeing before, but they're all centered around 0, and that happens because these scores, when they are calculated by the machine, they are designed to be standardized so you can compare different factors between them.
So if we look at a summary of model2 $ scores using the summary function, what we're going to see is that the mean is 0.
So that means that the scores are standardized, and it gives us the ability to compare different factors. However, it makes very difficult the interpretation. Essentially, we would have to de-standardize the scores every time we want to interpret something.
Let's also just be clear, when we talk about interpret, we mean explain it in the real world.
Yes,
so
exactly,
if you were saying to a brand manager that the purchase intention of these respondents is this, if you use this regression method, you would say the average purchase intention is 0.
Which doesn't make any sense. We know that's not the case in our data, so we know that our data range from anywhere from 0 to 11 or 1 to 10, so our purchase intention, the average is definitely somewhere between those bounds. So
it's
0.
Definitely not 0.
It's definitely not 0. So So
what that would allow us to do is if we got several different factors and we wanted to look at relationships between them, because they're standardized, they're not reliant on the scale. So you can have one set of items that might be 0 to 5, one set of items that might be 0 to 20, and it standardizes them with a mean of 0, so you can compare them. But interpreting them in the real world, saying what they actually means, it's meaningless. So what else could we do?
So we have, as we were saying before, most psychometric scales are summative, so you can either calculate the sum or the average. In marketing, we tend to calculate the average, again because it is exactly as our measurement scale, so the average will always come from 1 to 5 or 1 to 10, depending on the measurement scale we've used, and we can directly interpret it in the real world.
Yeah, so what we can do is if we create a mean, which we started out these videos saying one of the problems with the means is that they lose the comparative value of each of the items.
Exactly.
But what it does let you say is something like the average purchase intention of men is 7 out of 10. The average purchase intention of women is 5 out of 10.
Yeah, exactly.
For example, and obviously if you're a marketer, that could be really powerful, practical information. So to do that, we're going to need to create factor means. So we're basically going to be averaging the items that we know are reliable and associated with each other. And we created that factor earlier on, which we call purchase intention, which is the 4 items which we know through our factor analysis and our reliability test are consistent. So now we can actually add a mean or an average of those to our data frame.
Rob, if I don't remember whether in purchase intention it's just the 4 variables or the 5 variables we started before, we can just call it up and take a look, right?
Yeah, so if we just click purchase intention.
Right, so we see it's the 4 items.
It's going to tell us what they are.
Cool.
So what we want to do is we'll create a new column in the data set. If this column already existed, purchase, it would write over the top of it.
Okay.
We know it doesn't, or it shouldn't, so it's going to create a new one. And what we're going to use is the apply function, and we're going to say apply this to everything in D and just the columns purchase intention. And then looking at the documentation, we have to add a 1. I'm not 100% sure why off the top of my head, but I'm sure we could look it up and find out why. And then we write mean, and I think this should hopefully work. So what it's going to do is say create a mean out of these items and the data in these items. No, it's not. Why not? Because
we forgot
I put a bracket in a square bracket.
Okay.
So there you go. So now if we type summary $$ purchase, so using the summary function, passing it just that one column which we've now created, which should be the mean of the 4 items purchase intention. Here we go.
So here we now know that the mean is 4.86. We are using a scale from 1 to 10, so that means that
we actually looked at this. We're
using 2 scales anyways. We're using a scale from 0 to 10 essentially, and a mean of 4.86 is almost in the middle. So people are 50-50 in terms of purchasing the particular brand as such.
Yeah, and this is, just looking at it, it looks like it's probably going to be about right. All these figures seem more true to life. And what we could then do is we can go back and use the save functions that we've already looked at, write .csv, and we could create a new spreadsheet with all this data in. Or we could start to use some of the graph functions, table functions in R to do it for us, which we're not going to do because we've done quite a few videos about this now, but that's what you could start to do to start to make your results look reportable, look pretty, look presentable, look persuasive, using all the kind of standard statistical reporting techniques that you would have learned. So I think that was everything I wanted to talk about.
That was it.
Great, well go on the wiki, go on the discussion forums,
and
ask some questions and continue on with these lessons.
Exactly.